by nature is complicated. So how much more is the world we thrive in? It is a complex place in one way or another, and I'm pretty sure that you are aware of that. Well, moving directly to our topic, if you're going to, search out or look for a predictive value of a certain variable, meaning to say if you're going to look for the root causes or the reasons behind the existence of a particular thing or event, it is oftentimes best to make use of more predictive variable to make that prediction. Yes, you heard it right. Oftentimes, because dumping more and more predictive value or reasons behind the existence of a particular event is never a 100% guarantee that you will arrive at the best explanation or accurate prediction. Why? Basically, there is a tendency that you will exceed with what your goal is. The very goal that you are to strive to at least fulfill to arrive is that to find variables that are the root causes of the existence of the particular event state, the dependent variable. And there's a tendency that if you are having a lot of independent variables or predictive value, these independent variables alone, instead of having a relationship only with the dependent variable, will have a relationship to one another. Say, predictive variable 1 correlates with predictive variable 2, and so on and so forth. And that's not an ideal thing. And if that is the case, it will not make things simpler, or to say it directly, it will get things complicated. So, to put that into context, we shall consider the question that goes, why does all the students of Bukidnon State University Senior High School got a more than passing or average grade? So in that scenario, in that situation, we are to look for both the tangible and intangible factors that trigger the existence of such event. And as you can perceive, as you can notice, there may be a lot of reasons or causes to that. Another question that we will be giving emphasis on is this. How or why does this person achieve or acquire this excellent or vibrant health? So you may see a lot of things, but we'll just narrow it down to the following. It could have been something to do with the diet that the person has. Number 2, could have something to do with the physical activity or the lifestyle that he or she engages him or herself with. Is he or she physically active or physically inactive or passive? That's a factor. Another thing is genetics. When I say genetics, you can say that this health status that, say, I am having is because it's inherited from my kindred. And another factor we can think of is the regular medical checkup. Another is the environment that the person is in. Is it suitable enough for us to have a good health, or it's very polluted, which is a great factor contributing to the health status that you are having. And lastly, though there's still a lot besides, is the number of hours of sleep or rest in order for us to to regenerate or replenish the energy that's being exhausted during that day. So probably you get the idea that the health status of a particular person is not basically based only in just a single piece of reason. There may be a lot of causes to that, and you can say that my health or your health status is mainly or only because of the diet that you have. No, it's not, because there are a lot of factors that triggers the existence of that particular event. And also with the earlier example that I tackled, which is the grade or the rating of the students of Bukidnon State University. Now, well, in the first place, why am I saying this anyway? The thing is, we'll be dealing with a statistical tool which will measure the relationships between variables. And talking about relationship, we have already the correlation coefficient, or the Pearson's R, which is effective enough to measure the relationship between two variables. One independent variable, or the predictor variable, and one response variable or the dependent variable. And that is the main point here. The limitation that such statistical tool poses deprive us to, to explain well or accurately predict the reasons or the root causes of the existence of a particular event. Just like our example earlier about the health status and the gradings or the ratings of the students of Bukso SSL. So that is the thing here that needs to be considered. But again, that's not a problem because we have the ever powerful statistical tool that will give solution to that problem or discrepancies, and this is the multiple regression.
Now, let's define multiple regression. Multiple regression is a statistical tool that allows you to examine how multiple independent variables are related to one dependent variable. Once the relationship between the variables is identified, you can start to take information about all of the independent variables and use it to make more accurate and precise in predicting and finding the answer. Also, it is an extension of simple linear regression that has only two variables, one independent and one dependent variable. Now, let's have the recap of the multiple regression. An extension of simple linear regression, a statistical tool used for testing between two or more independent variables to one dependent variable.
I'm here to differentiate the statistical tools linear and multiple regression. Linear regression measures the relationship between one independent variable and one dependent variable, while multiple regression measures the relationship between at least two independent variable and one dependent variable.
So now, let's talk about the significant result of a multiple regression analysis. What is p-value? P-value is a measurement that tells us how much with the observed data disagrees with the null hypothesis. When p-value is low, there is more disagreement of our data with the null hypothesis, and we can consider rejecting the null hypothesis. It can be that the groups being studied are less likely same. Therefore, if our p-value is very small or low, our data is incompatible with the null hypothesis, so rejected the null hypothesis. However, if the p-value is high, it is other way around, meaning there is a less disagreement between the data and null hypothesis, and the groups being studied are the same. What determines whether the p-value is less or high? Here comes the level of significance, alpha. If the p-value is lower than alpha, we can infer that there is a statistically significant difference between groups. Alpha is usually 5% or 0.05.
Now, there are other significant results from the multiple regression analysis. The F-value. The F-value is statistics that test overall significance of the regression model. It is the ratio of the mean regression sum of squares divided by the mean error of the squares. Second is the R-square. R-square represents the scatter around the regression model or the regression line. Now, let's talk about scatter plot. Scatter plot is a graph in which values of the two variables are plotted along the two axes. Scatter plot shows how much variables are affected to each other. And the relationship between two variables is called the correlation.
Here's the relationship between p-value
And R-square.
low r-square and low p-value. So the value of the p-value is less than 5%. So it means that your model doesn't explain much about the variation of the data, but it's significant. So low r-square and high p-value. So the p-value is greater than 5%. Your model, it explains that your model doesn't explain much of the variation of the data.
High R-square and low p-value. The model explains that a lot of variation within the data is significant. High R-square and high p-value. means that your model explains a lot of variation within the data but is not significant.
So now let's move to the uses of the tool multiple regression. First is predict or explain a person's current compensation based on a number of employee characteristics. Second is predict or explain patient survival after surgery based on a number of personal characteristics. And last, predict the likelihood of a recently released convicted criminal reoffending based on a number of personal characteristics. As you notice, the bottom line here is that we can use the multiple regression tool to measure how multiple independent variable correlates with a single dependent variable.
So here are the steps in conducting multiple regression analysis. So first, generate a list of potential variables, the independent and the dependent variable. So if the independent variable is at least 2 independent variables and 1 dependent variable. So in generating a list of potential variables, you should be wise enough in choosing them. So second is collect data on the variables. So collecting data on variables is like gathering data on a case and on a case or the case study. And third is check the relationship between each independent and the dependent variable using scatter plot and correlation. So here is an example of a scatter plot. Scatter plot and correlation determines the relationship of the dependent and the independent variable. So third is optional in conducting multiple regression analysis. It is conduct simple linear regression for each IV and DV pair. So next is use the non-redundant independent variables in the analysis to find the best fitting model. And lastly, use the best fitting model to make predictions about the dependent variables. So as we all know, the examples of fitting models are the line graph, histogram, and the pie graph. It is best in interpreting and analyzing your data.
So in this illustration, it shows the data that we have gathered. For the first 3 columns, we have here the 3 independent variables, which are the miles traveled, the number of deliveries, and the gas price. While the last column shows the dependent variable, which is the time traveled. Now, what I can only say here is the greater the variation, the more it is accurate.
And now, we are sketching the relationship of multiple regression many to one. As we can see, there are 3 independent variables and 1 dependent variable. It is necessary that the independent variable has strong relationship with the dependent variable, while we need to make sure that this 3 independent variable has no relationship among each other to avoid complication.
So, let's go for the new considerations. Adding more independent variables to a multiple regression procedure does not mean that the regression will be better or predict better results. Well, in fact, it can make things worse and create more problems. When this happens, this is called overfitting. The addition of more independent variables to a multiple regression procedure will create more relationship among them. So, not only are the independent variables potentially related to the dependent variables, but they are also potentially related among each other. When this happens, this is called multicollinearity. The ideal is for all independent variables to be only correlated to the dependent variables, but not within each other.
It's now 2017 and 21st century has brought us much advantages, especially when we talk about technological advancement and its implication to our lives. And eventually, it has made things a lot easier for us. For now, we are going to obtain multiple regression analysis utilizing the MINITAB application. Multiple regression analysis on MINITAB. So we have here the data legend or dictionary. Dependent or response variable is the intelligence quotient or the IQ score. The predictor variable or the independent variables, namely brain size, height, and weight. So our claim is a null hypothesis. Null, by definition in statistics, is zero or zero relationship. We are claiming that brain size, height, and weight do not affect the IQ score of a person. So let's find it out. first step, input your gathered data on a MINITAB. So we have in the first cell, the IQ. In the second cell, the data of brain. In the third cell, the data of height. And in the fourth cell, the data of weight. The next step is we're going to determine whether there is an existing relationship between our variables or not. So go to graph, then click matrix plot, and the box will pop out. Then choose simple and then click OK. So another box will pop out and we're going to input the variables and we're going to view the relationship through the graph. So we have here IQ up to weight, IQ, brain, height, and weight. Then click OK. After that, this graph will appear. So disregard this portion because it's not that significant. We'll be focusing the topmost part because this is the graph of IQ versus brain, this one, IQ versus height, this one, and the last one is the IQ versus weight. So here it is. As we can see, there's actually no strong relationship between the variables, but at least we have the brain and the height, which is somewhat, it affects the IQ or the intelligence quotient of a person.
Next is to analyze the data. So click the stat, the regression, and the fit regression model. So it will come or pop up a box, and in responses, input IQ or the dependent variable, and the continuous predictor, the independent variable, which are the brain, height, and weight, and click OK.
So here we go, the regression analysis of the IQ versus brain, height, and weight. So for the analysis of variance, we'll be focusing only on the regression part, specifically the F value and the P value. And as we notice, P value here is low, but what determines it in the very first place is the significance level, which is 0.05. And if it exceeds with that amount or value, then it's already considered high, or we can infer that there is no existing relationship between the two. But since it's 0.07 and it is low, we can infer that we have the enough supporting evidences that we are going to reject the null hypothesis in the very first place. And another thing that we shall consider is the F value, which tests the overall significance of the regression model or our independent variables. It also tests the null hypothesis that all of the regression coefficients are equal to 0. And the next, we have the R-square adjusted, with which, if it is larger, then it is better because it determines the portion that the predictor variables has on the response variable. And also, it becomes smaller if you include extra variables or data into the model that don't relate to the response variable. And the next, we have so another value that needs to be put into consideration is the coefficient, which indicates the relationship that the independent variables have with the dependent or response variable, either positive or negative. Positive when it is directly proportional, and negative when it is indirectly proportional. That's it. So the next step that we are going to do is to determine the best model through eliminating variables. And we are going to do it one at a time. So earlier, we arrived to the result that goes like this. This one. So for our R-squared adjusted, its value is 23.27%. And we're going to reiterate the process again, eliminating the weight, because as we can see, it has no relationship with the dependent variable because its p-value exceeds with 0.05, which is the standard significance level. So let's reiterate the process, but in the absence of weight. So go to stat again, regression, and fit regression model, and this time we are going to eliminate the weight as what I've said. So we have the response IQ, and for the continuous predictors, you have only brain and height, then click OK. So by doing that procedure, we arrive with these results. We have the R-squared adjusted, which becomes larger, and it's good because the larger the R-squared adjusted is, it will be better because it determines the portion that the predictor variables has on the response or the dependent variable. And for the p-value, as we can see, these are all under the 0.05 standard significance level, and it is good. But we're also going to input brain for the continuous variable alone as the last process in order for us to determine which among the models fit the which among the models will really fit for us to arrive at a good conclusion. So it so happens that the R squared adjusted becomes low or lower, and this indicates that this is not the best model. So we have here brain and height as the best model, indicating that these two variables affect the IQ score of a particular person, considering the value on the R squared adjusted.
So now, what could be our conclusion? Shall we reject our null hypothesis?
Well, there is enough supporting evidence that we are going to reject our null hypothesis because based on the results, particularly the p-value and the R-squared adjusted, there is an existing relationship among our variables. That is, for the two independent variables, the brain and the height, and that is excluding, of course, the weight.
So what could be our real-life implication?
Based on the coefficient result, we can infer that the height and the brain size of a particular person affects his or her IQ score. For the brain, it affects our IQ score positively or directly. So the larger the brain size, the higher our IQ score, and that's the result. While for the height of a particular person, the taller you are, the lower your IQ score. It's kind of weird, but that's the result. So, as for the weight, it does not affect the IQ score of a particular person at all.